Hi, my name is Armon Dadgar, and I want to talk a little bit about Terraform today. So Terraform, if you've never heard of it, is our tool for doing provisioning. So when we talk about provisioning, there's really two different problems we're talking about, right? So as we provision, there is our day one challenge, where we haven't actually started running anything yet. And so how do we go from running nothing to running something? And then there's actually our more challenging day two plus, which is great, day one we had nothing and we provisioned our initial set of infrastructure, and then day two we have an existing set of infrastructure, but we're trying to evolve it. We're changing it over time, we're adding new services, removing services, and generally evolving the way our infrastructure looks. So how does Terraform really solve this problem? We fundamentally believe in taking an infrastructure as code approach. And so what I mean by that is we allow you to declaratively define in sort of a set of Terraform config files what you want your infrastructure to look like. So in something that's very simple and human readable, you describe your overall topology. And so what I mean by that is when we talk about infrastructure, there's many moving pieces. I might have a VPC or my core network. On top of that, I might provision my security group rules, the way my network security is set up. And then within that environment, I define my set of virtual machines. I might have some VMs that I want to provision. And then overlaid on top of that, I have a load balancer. And so you can imagine how this graph extends over time. I add different pieces, different amounts of complexity to it, and I incrementally evolve my infrastructure day over day, week over week. And so while this is sort of graphical in nature, the way we capture it in a Terraform configuration is very lightweight in describing sort of high-level resources. We describe the VPC resource and the fields that are required to create this element of our infrastructure. And then as we define these other things, we can reference the other components of our infrastructure. And so what Terraform then does is gives us a workflow for creating and managing this. And ultimately, this is sort of three different main commands that we run. The first command is Terraform Refresh. And what Terraform Refresh does is basically reconcile what Terraform thinks the world looks like, so Terraform's view of our infrastructure, with the real world. And so how this works is Terraform goes out and talks to the real world. It'll query our different infrastructure providers, whether that's VMware or Amazon or Azure, and ask them what's actually running. And so in this way, Terraform gets an up-to-date view of what our infrastructure actually is. Then we run a plan. And a plan is where Terraform figures out what it needs to do. And so you can think about a plan as reconciling sort of the real world, what things are actually running, with what we want to be running, our sort of desired configuration. So when we talk about Terraform's configuration, what we're putting into this graph, this is our desired state of the world. This might not actually be the world as it is. So as an example, on day one, when we execute this, nothing is yet running. So when Terraform runs the plan, it realizes that there is nothing yet running in the real world. So to get to this desired configuration, Terraform needs to boot all four of these resources. And so this becomes the plan. Terraform will give us an output that says, to bring the world to look like what you want it to be, I'm going to go boot these four things. So then the last part is actually doing this. This is the apply phase of Terraform's execution. So when we apply Terraform's execution, it starts with our plan of what we need to do, and it goes out and executes it against the real world. And so in doing this, Terraform will go out and figure out what is the right order in which these need to be done. So there's a natural dependency here. The network must be defined first before we can define the security groups around it. Once those are defined, we can boot all of our VMs, whether we're booting one or booting hundreds of these in parallel. And Terraform will figure out where it has that opportunity to create things in parallel and where it needs to be sequential. And once these VMs are available, then Terraform can lastly create our load balancer and say, all done. So this gives us a way to do our day one infrastructure. So day one, we described what we want our universe to look like. We ran Terraform Refresh. It said there was nothing existing. Plan said all of these things are going to be created. And then apply goes out and builds it. What now happens over day two is we start evolving our infrastructure. So where this was our infrastructure day one, day two we might come in and say, I really want a DNS record that points to my load balancer. I want to have a content distribution network like Fastly sitting in front of that. And I want my VMs to be connected to a monitoring system. So I might monitor these different VMs. And so now we change our Terraform configuration. We enhance it by adding the definition of these other elements to our TF config. and we rerun the exact same workflow. So when we run refresh, Terraform will realize these first 4 resources exist, but these new ones do not. And so when we run our plan, it'll tell us that nothing needs to be done with these 4. They already exist and they're in the desired state, but that we must add 3 new elements to get to where we need to be. And so now when we run Terraform apply, it goes ahead and talks to the real world and adds these 3 new things and brings the world into looking like our desired state. The advantage of this workflow is a fewfold. One, our day 1 experience is identical to our day 2. And this really is important because day 2 is sort of forever. This is something we're going to keep doing. And then the other advantage of this is something we actually skipped, which is day n, when we decide we might need to decommission this. We don't need this service anymore. We don't want this infrastructure. Maybe this was just a staging environment or a test environment. We then have the option to come in and destroy. And when we do a destroy, it's basically an unwinding of everything that's been done, right? In some sense, it's a specialized version of apply, which really creates a special destroy plan, and then goes out and talks to the real world to destroy all the elements that exist. And so now we can efficiently, at the end of our life cycle, go from nothing to something, evolving it day over day, and in the final day when we need to decommission it, Terraform knows how to clean up all the resources associated with that application. So far everything we've talked about is really about the workflow. This is not specific to any technology. So how does Terraform actually make any of this stuff work? This is where Terraform's architecture becomes important. So when we talk about the way Terraform actually works, there's sort of 2 major components. One is Terraform's core. So the monolithic core is responsible for a few things. It takes the Terraform configuration, which is being provided by the user, and then it takes Terraform's view of the world, or Terraform's state. This is managed by Terraform itself. And so these get fed into the core, and the core is responsible for figuring out what is that graph of our different resources. How do these different pieces relate to each other? What needs to be created? What needs to be updated? What needs to be destroyed? And so it does all of the essential lifecycle management. On the backside, Terraform supports many different providers. And providers are how Terraform connects out to the rest of the world. So these can be things like cloud providers, things like AWS or Azure or GCP. They could be on-premise infrastructure, so things like OpenStack or VMware. But it's not restricted to just infrastructure as a service. Terraform can also manage higher level things, platforms as a service, such as Heroku or Kubernetes or things like Lambdas. So these are higher level than what we would traditionally consider infrastructure as a service, more in the realm of a platform as a service. The other types of things Terraform can manage are pure software as a service, very high level things, maybe monitoring like Datadog, or CDNs like Fastly, or even things like managing GitHub teams. So these are what we'd consider pure software as a service. These are externally managed services. But the view that we take as Terraform authors is that all of these pieces are connected. When I talk about a modern infrastructure, I might be composing all of these different resources. So I might have some set of my infrastructure that is infrastructure as a service, and then I might compose that and say, you know what, I'm going to provision a Kubernetes cluster. And on top of my Kubernetes cluster, I'm going to define a namespace, and I'm going to define services. And so these now exist on top of infrastructure as a service, and I might compose even these with higher level things like DNS and CDNs. And so all of these are important pieces of our infrastructure. We can't deliver our application without the IaaS, without the platform as a service, and without the higher level software as a service. They're all part of our logical end-to-end delivery. And what we want to get to with Terraform is a single unified workflow. We don't want it to be, you use one tool to manage this, and now you have to figure out how you get past this disjoint experience to manage the next section, and then another disjoint experience, and you have to piece together all these things. Instead, anything that really has an API and has a lifecycle associated with it, how can we enable that to be a provider such that Terraform can help us solve this problem end to end? And this is really where providers come in. Today we have over 100 providers, and those individually can manage over 1,000 different resources, where a resource can be an AWS EC2 VM, or an Azure Blob Store, right? These different types of resources or anything that a cloud or even these higher level things expose. And that list is constantly growing. Terraform is an absolutely massive open source project with thousands of contributors, and so every day there's new providers and new resources. So how does this really start getting used at different levels within teams? So this becomes an interesting workflow question around how you actually manage Terraform. So initially, this goes back to that core workflow we talked about. So we start with a single individual practitioner who's using Terraform locally. And their workflow is to start by writing some Terraform configuration. Then they run Terraform plan. Plan tells them, what is this configuration going to do? What does Terraform think needs to be done to apply these changes? And if this looks good, the practitioner will apply the changes, and then this cycle continues. They continue to evolve the infrastructure. This might look very similar to software development, where we're writing some code, we're applying unit tests, we're committing those changes, and then we're continuing our cycle. So what happens is we go from a single individual to now we add multiple team members. We have other people we want to collaborate on managing the same infrastructure. Well, there's a few challenges, much like with software writing, which is how do we make sure we have a consistent view of what the configuration actually is, and how do we make sure we don't step on each other's toes and run multiple changes in parallel? So if we both try and add 5 new VMs, how do we avoid booting 10 new VMs instead? So this problem, in some sense, ends up being very similar to the problem of using Git locally versus using Git as a team. So as we go to a team, we use a system like GitHub to provide that central collaboration. And so our equivalent of that is what we call Terraform Enterprise. So the Terraform Enterprise workflow augments this a little bit. So what we would do, instead of now running it locally and running these coordination risks, as an individual, we're still writing our Terraform and planning locally, but now we're pushing that into a version control system. So this could be GitHub, could be Bitbucket, could really be anything. But the idea is, how do we move to having a central repository where we're managing this and coordinating, much like we do for source control? And then we drive off of this our Terraform Enterprise application. And the goal here is a fewfold. One is, how do we make sure the state management is done locally? So like I said, Terraform keeps track of all the resources it's provisioned so that it knows at destroy time what it needs to tear down, or as we incrementally make changes, what already exists. So this state file is an important thing to have centrally managed so it doesn't diverge or end up with sort of different lineages where we fork off and then independently run Terraform, and now the state files conflict with one another. So by managing that centrally, we avoid those sort of conflicts. The other important advantage here is that we make sure we're only doing one run at a time, right? So we ensure there's the sequential application. So if Alice and Bob are both working on the same infrastructure and they both try and make a change, they don't step on each other's toes. Lastly, one of the challenges is oftentimes in this environment, developers are using local variables to populate things like AWS IAM keys or other sensitive credentials. And so we don't want these sensitive credentials to be strewn about on all of our developers' machines. Instead, we want those variables to be kept centrally and encrypted so that we don't have to worry about these things getting exposed or leaking out in plain text. We can put them in a central place, and version control and access control who can actually modify and view these things. So this sort of changes our workflow and now enables a handful of people to collaborate safely together. Well, what starts happening as we start wanting to add even more people, right? So for example, we might be going from sort of our early operators who are very familiar with the cloud environment to exposing it more to our development groups. This is where Terraform's notion of a module comes in handy. So a Terraform module is sort of like a black box of infrastructure, where what we can define as a set of input variables that let us toggle the behavior of this module, and the module might emit a set of output variables. So an example of this might be, I might define a module for doing Java, for deploying my Java application in AWS, and my inputs might be, what's the path to my jar, and how many instances of my Java application do I want? And now inside this module, we can operate as a black box and deploy either VMs using EC2, we can deploy Lambda functions, we could deploy containers with ECS. All of these become a detail hidden within this module that a consumer doesn't need to know about. And their output can just be, what's the address of the load balancer that hits my application? So in this way, we encapsulate that complexity and make it more accessible to a broader audience. So how do we actually manage and share these modules? In general, we publish these things to a central registry. So there's a central registry that exists today for Terraform. If you go to Terraform registry.terraform.io, that's our global public registry. And there you'll find hundreds of modules that cover common forms of infrastructure, common architectural patterns, and many of these are actually published by the cloud providers themselves. So you can log in and see Google's official recommendation for how to provision their network, or Azure's official recommendation for how to manage a virtual network inside of Azure. And so these modules make it much more consumable for us to operate in these environments because we don't have to know every detail of it. We can just go and say, I want a network in Amazon or Google or Azure, and fill in a few of the inputs that matter to us and let the module take care of the rest of the complexity, right? And so this same idea can be extended to different applications, different types of infrastructure. One way we can apply this same pattern internally to our organization is by running a private registry. So instead of using the public registry that's available sort of globally, we can run a private registry within our organization. And this is a capability integrated into Terraform Enterprise. And so what this really lets us start to do is make this split between the set of people internally who are publishers and are familiar with our internal infrastructure and how it should be managed in cloud environments, and they can push in to basically a catalog or a module registry, all of the different key patterns that are needed. So we might publish, here's how we do a Java app, here's how we do a C# app, here's how we do a database, and expose this out to our internal developer community. And then our much larger base of consumers can simply go into the catalog and pull out the things they need. And so these consumers can know much less about how cloud works, but still get these approved modules that are sort of the best practice internally, right? And there's sort of a few ways of consuming this. For people that are more familiar with Terraform, they can consume it just like a normal Terraform module and do an infrastructure as code approach. For folks that are less familiar, they might want to take more of a WYSIWYG approach. And they can do that with Terraform Enterprise by selecting their modules, filling in the different variables, and basically letting the system automatically generate the equivalent Terraform for them. So they can either use that equivalent Terraform as a starting point and customize it further from there, or if they have really no interest in learning and using Terraform directly, they can just use the auto-generated Terraform and self-service their infrastructure. And so our goal really becomes, how do we enable this large audience of consumers to get to self-service on infrastructure in a way that is still going to be compliant with how the business wants to do it and not create this immense workload on publishers to constantly generate custom infrastructure and custom definitions for the vast body of consumers within an organization. So at a snapshot, this is Terraform. This is how it applies an infrastructure as code approach to provisioning, really looking at both the day one challenge and, more importantly and more challengingly, the day 2+ challenge. And then the natural journey as we go from a single individual using Terraform to a small team to kind of an entire organization who's trying to leverage Terraform for infrastructure management. If you're interested in learning more about Terraform or Terraform Enterprise, I recommend checking out our online resources. Thank you.